Whew. In this podcast, we are going to go over some radioactivity conversion problems. Since this is an optional podcast, use what you want. My recommendation will be to pause on the problem before I do any talking or any work the problem, and then check in with me to see if you did the problem correctly. All right, we're going to start where we always start, and that's by reading the problem and identifying our known information. So we see a patient is administered iodine 131. They need a dose of 14.3 millicuries. If the solution contains an activity of 6.5 millicurie per milliliter, what volume of the solution needs administering? Okay, so we have a lot of good information here. Looks like we are starting in millicuries. Our patient needs a millicurie dose, and they want to know what volume, and they don't give us any specifics on what unit to use. So I'm just going to pull the volume out of this conversion factor. So we're going from millicuries to milliliters, and I am seeing right here that we have a millicurie per milliliter, and remember that those can be written as conversion factors. So that's the same thing as saying 6.5 millicuries per 1 milliliter, or 1 milliliter has 6.5 millicuries, and so we can flip-flop that as needed to cancel units. So setting up our T-chart, 14.3 millicurie, and the conversion to get from millicuries to cancel millicuries and get to milliliters is the dosage. Now keep in mind, when we are figuring out significant figures, this is a dose, this is a medication, this is a measured amount. So we're also going to include that when we determine how many sig figs for our final answer. All right, if I plug in this conversion factor as written up here, I'm not going to cancel millicuries. So I'm going to go ahead and flip that. And I'm going to put milliliters on the top and 6.5 millicuries on the bottom. So that will cancel my millicuries, leaving me in milliliters, which is exactly what the problem asked for. All right, I'm not going to put the number 1 on milliliters because that will kind of confuse my sig fig issues here. So 14.3 divided by 6.5 gives us 2.2. That's straight out of the calculator. And just double checking sig figs, we've got 3 here and 2 here. My least in the problem is 2, so this is good as written. Your patient will need 2.2 milliliters of that to get 14.3 millicuries. All right, very similar problem here, so this would be a great time to pause it and try this on your own. A patient must be administered a 32 millicurie dose of technetium 99M, which is supplied in a vial containing a solution with an activity of 12 millicurie per milliliter. So that's my dosage. It's also a conversion factor. What volume of the solution must be given? So again, I'm not given a unit for volume, so I'm just going to use milliliters and make my life easier, and that's one less conversion to do. All right, so we are starting in millicuries, but I am trying to find milliliters. And to convert from millicuries to milliliters, I have this conversion factor, 12 millicuries per milliliter, that I'm going to use. So let's go ahead and set up our T-chart. We know we have we need 32 millicuries for our dose. And we have a vial that has 12 millicuries per milliliter. Well, looking at our conversion factor, if I plug that in as is, I'm not going to cancel millicurie. So I'm going to need to flip that, and I'm going to put the 12 millicuries on the bottom and my milliliters on the top. So my millicuries will cancel, leaving me with milliliters. So 32 divided by 12, straight out of the the calculator, gives us 2.6666666 forevermore. Looking at the number of sig figs in the problem, I've got 2 here, and this is a measured dose, so it's an inexact number. You would include this for determination of sig figs. Both have 2 sig figs. My answer needs to be rounded to 2 sig figs. So 6 tells us to round up to 7. The answer is your patient needs 2.7 milliliters of your dosage. So we are jumping from a pretty easy conversion question to an incredibly difficult one, but that's a good thing because we can do hard things. Radioactive sodium-24 is administered as sodium chloride, and it's given to treat leukemia. If a patient must receive 180 microcurie per kilogram, and the isotope is supplied in a solution that contains 5 millicurie per milliliter, what volume, okay, I'm just going to use milliliters because that's the only volume that's been used, it's one less conversion, is needed for a 75 kilogram patient? Okay, this one's a little bit tough. I definitely want to draw my unit map. That's going to keep me organized. So I think the easiest place to start here is thinking about our patient that's 75 kilograms, because some of these dosages are per kilogram, and that way we're not starting with a unit that has something both in the numerator and the denominator. So if we start with kilograms, we know we want to get to milliliters eventually. I don't know how much space I need, but I'm just going to give it a lot of space here. So the first thing I want to look for is a conversion factor that has kilograms in it and see where that gets us. So that's going to be this number right here. Okay, I can go from kilograms to microcuries. So we know that we have 180 microcuries per kilogram. Okay, kilograms will cancel, leaving me in microcuries. Now, I want to look for another conversion factor that would help me to cancel our curies and get us to milliliters. And the obvious choice would be right here, but I have just a little bit of an issue. This dosage, this prescription, is millicuries per milliliter, and I'm currently in the unit of microcuries. Thankfully, this is just a metric conversion, and the difference between micro and milli is 1,000. So I can convert to millicuries. I know that 1,000 microcuries are in every millicurie. So I can use that as a conversion factor. Finally, to get from, let me give myself a bit more space here. And finally, to get from millicurie to milliliters, now I can use this conversion factor as written. So I know that I am going to cancel. I'm going to put the millicuries on the bottom and the milliliters on the top. That'll cancel millicuries. And I've essentially set up my T-chart. And so the reason that we always ask you to do these unit maps is because it becomes really helpful. It's the hard part of it before you even do any calculations. So setting up our incredibly long T-chart, I want to start with 75 kilograms. I'm right here. I'm going to plug in this first conversion factor, and I've written my conversion factors in a way that will cancel units. That's also really helpful. So I'm going to cancel out my kilograms by putting microcuries on top and kilograms on the bottom. If you are a visual person, you might want to change the colors too. I like changing colors to show where I am. So we are now here in microcuries. I need to go from microcuries to millicuries, so I'm going to use this next conversion factor. And again, I wrote it in a way that shows them canceling. So I have 1,000 microcuries per 1 millicurie. And remember, we're not using these we're not using this conversion factor in our sig figs because it is an exact number. It's just a conversion factor within the metric system. I'm now here, and I'm ready for my last conversion, which is going to use that prescription amount, that 5.0 millicuries per milliliter. So I'm going to put the millicuries on the bottom to cancel, and that should leave me with milliliters, which is what I was asked for. I'm going to multiply across the top, and I'm going to multiply across the bottom and divide top by bottom. And it's highly recommended that you do this in one fell swoop using parentheses. That gives you less to copy down and less chances of calculator errors. So when I do that, straight out of the calculator, I get 2.7 milliliters. And I'm going to double check my sig figs now. I have 2 sig figs in the 180 because there's no decimal, 2 sig figs in the weight, and 2 sig figs in the dosage. So my answer should also have 2 sig figs.